Hello, Daniel here from howtomechatronics.com. In this tutorial, we will learn how to control individually addressable RGB LEDs or a WS2812B LED strip using Arduino. First, we will explain the working principle through some basic examples and then take a look at a really cool Arduino project using these LEDs, a DIY interactive LED coffee table. The coffee table features WS2812B LEDs, infrared proximity sensors for detecting objects, and a HC05 Bluetooth module for controlling the colors via a custom-built Android application. This project is actually a collaboration between me and Maria from Creativity Hero YouTube channel. For more on this, you can check the description as well as watch this video till the end. Let's start by taking a closer look at the LED strip. It consists of type 5050 RGB LEDs, in which the very compact WS2812B LED driver IC is integrated. Depending on the intensity of the three individual red, green and blue LEDs, we can simulate any color we want. What's great about these LEDs is that we can control even the entire LED strip with just a single pin from our Arduino board. Each LED has 3 connectors at each end, 2 for the powering and 1 for the data. The arrow indicates the data flow direction. The data output pad of the previous LED is always connected to the data input pad of the next LED. We can also cut the strip to any size we want, as well as distance the LEDs using some wires. As for the powering, they work on 5 volts and each red, green and blue LED draws around 20 mA, or that's total of 60 mA for each LED at full brightness. Note that when the Arduino is powered via the USB, the 5V pin can handle only around 400 mA. And when powered using the barrel power connector, the 5V pin can handle around 900 mA. So, if you are using more LEDs and the amount of current that they would draw exceeds the limits mentioned above, you must use a separate 5V power supply. In such a case, you also need to connect the 2 ground lines to each other. Additionally, it is recommended to use a resistor of around 330 ohms between the Arduino and the LED strip data pin in order to reduce the noise on that line, as well as a capacitor of around 100 microfarads across the 5V and ground to smooth out the power supply. Now, as an example, I will use 20 LEDs long strip connected to the Arduino through a 330 ohms resistor and powered with a separate 5V power supply. For programming the Arduino, we will use the Fast LED library, which can be downloaded from GitHub. This is an excellent and well-documented library which enables easy control of the WS2812B LEDs. So first we need to include the Fast LED library, define the pin to which the LED strip data is connected, define the number of LEDs, as well as define an array of type C RGB. This type contains the LEDs with 3 1-byte data members for each of the 3 red, green and blue color channels. In the setup section, we need to initialize the fast LED with the parameters we defined above. Now, in the main loop, we can control our LEDs anyhow we want. Using the CRGB function, we can set any LED to any color using the 3 parameters of red, green and blue color. In order to make the change happen on the LEDs, we need to call the function fastled.show. Using some for loops, we can easily make some interesting animation. Here, the first loop lights up all 20 LEDs in blue, from the first to the last LED with 40 milliseconds delay. The next loop lights up again all 20 LEDs, but this time in red color and in reverse order, from the last to the first LED. The Fast LED library features many other functions which can be used for making really interesting animations and light shows, so it's only up to your imagination to make your next LED project shine. Now let's take a look at the DIY interactive LED coffee table project that I mentioned at the beginning of this video. So this was a collaboration project between me and Maria from Creativity Hero YouTube channel. You can watch her video where she explains the entire process of making the table, starting from cutting and assembling the wooden construction to soldering and connecting all electronic parts together. Here I will explain how the electronics part work, how to build the custom Android application and program the Arduino board. Here's the complete circuit schematic. So the table consists of 45 addressable LEDs, 45 infrared proximity sensors and a HC05 Bluetooth module, all of them connected to an Arduino Mega board. The circuit is powered via a 5V 6A power supply. Here's the Arduino code for this project, and if we exclude the Bluetooth color control feature, we can notice that the code is actually really simple. First, we need to define the basic parameters as explained earlier and set the 45 proximity sensor pins as inputs. In the main loop, using a single for loop, we set all LEDs to a particular color and also check whether the proximity sensor has detected an object. If that's true, or a low logic state in this case, the particular reactive color will be set to the particular LED. At the end, using the fastLED.show function, we update the LED's colors. For including the Bluetooth color control feature, we need to add some more lines of code, as well as make the Android app. I already have separate tutorials on how to use the HC05 Bluetooth module with Arduino and how to make your own Android application using the MIT App Inventor online application, so you can always check them for more details. Here's how the Android app works. It consists of a color palette image from where we can pick up colors, two checkboxes from where we can select whether the chosen color will be applied to the reactive or the background LEDs, and a slider for adjusting the brightness. If we take a look at the blocks of the app, we can see what happens when we touch the canvas where the color palette image is placed. Using the getPixelColor blocks, we get the red, green and blue values for the picked up color, and using the Bluetooth sendText block, we send this information to the Arduino in a form of text. Depending on the selected checkbox, we send a different first character or a marker, which helps when receiving the text at the Arduino. The same happens when we change the position of the slider. A value from 10 to 100 is sent to the Arduino in a form of text, with the marker tree in front. Here's the Arduino code that receives this data. First, we need to define the serial communication between the Arduino and the HC05 Bluetooth module, or the pins to which the module is connected. In the setup section, we need to set the baud rate at which this module works. Then, in the main loop, using the Bluetooth.available function, we check whether there is an incoming data from the smartphone. If that's true, using the Bluetooth.readString function, we receive the data as string. Then, using the startSwitch function, we check the first character or the marker, and in that way know whether we want to change the reactive color, the background or the brightness. Using the substring function, we extract the red, green and blue values from the received text and convert them into integers. These values are then used in the for loop below, which sets the color and lights up the LEDs as explained earlier. In the same way, we adjust the brightness of the